Good. Now, question 7 says that find the Fourier series for the function f of x equals to cos lambda x. Lambda is not an integer, and x lies between minus pi to pi. Now, because we know that cosine function is always even, is even in the whole R, and we have been given a symmetric interval. Therefore, this function is even in this interval given because we have minus pi to pi. So therefore, we just our Fourier series for this one will just be a naught over 2 plus summation n1 to infinity of an cosine of nx. So let's solve the equation quickly. So question 7. So the function is even. Hence, bn equals to 0. And then a naught would be given by integral. So remember the period is also 2 pi, so 1 over pi from, so 2 over pi, 0 to pi, and then f of x given by cosine of lambda x dx. So this will give us 2 over pi into sine lambda x over lambda 0 to pi. And when you put in the limits, so you get this is the same thing as saying 2 lambda pi sine of lambda x, then 0 to pi. So which tells us that now because this is not this lambda is not an integer, then upper limit will be just 2 over lambda pi and then sine lambda pi. But this one is 0, so this is what we have as our a naught. And then an will be 2 over pi 0 to pi cos lambda x times cos nx dx. Now this one you use double angle formula to get 1 over pi integral from 0 to pi cosine of lambda plus n x plus cosine of lambda minus n x dx. So which will be an equals to 1 over pi into sine lambda plus n pi divided by lambda plus n, and then plus sine lambda minus n pi over lambda minus n, which will give us an equals to 2 over pi and then lambda minus 1 raised to power n, lambda squared minus n squared, and then times sine of lambda pi. So what you have done here is just to put these terms together, putting under one LCM. And then, therefore, cosine of lambda x will be a naught divided by 2. And then remember, a naught is this value here. So dividing this one by 2, you get just sine lambda pi over lambda pi. So sine lambda pi over lambda pi. That's what we have. As our a naught, and then plus summation an is 2 over pi lambda minus 1 power n over lambda squared minus n squared sine lambda pi times cosine of nx. So which means we'll have cosine of lambda x equals to sine lambda pi over lambda pi, and then plus so I can factor out 2 lambda and then sine lambda pi divided by pi, and then summation, so n from 1 to infinity, n from 1 to infinity of minus 1 power n cosine nx over lambda squared minus n squared. So this can be written as cosine of lambda x equals to sine of lambda pi over lambda pi plus 2 lambda sine lambda pi over pi into, so when n is 1, I get 1 minus 1. Also, or let me factor out negative. So I put here negative 2, so that now I have negative 1, so I have cosine of x over lambda squared, and then minus so when I put, so I start, so 1, so 1 have minus 1 lambda squared minus 1 squared, and then minus cos 2x over lambda squared minus 2 squared plus cos 3x over lambda squared minus 3 squared, and then minus other terms of the same pattern. So this can as well be written as cos of lambda x equals to, so here I have, if I compare these two terms here, I can put, I have sine of lambda pi over pi over pi into one over lambda, and then minus 2 lambda, and then into cos of x lambda squared minus 1 squared minus cos 2x over lambda squared minus 2 squared plus cos 3x over lambda squared minus 3 squared minus other terms, same pattern. So there are two brackets now. One to take care of the first, this one, and then this other one here. So this can be as well be written as, so when we put if x equals to pi, then we have cos of lambda pi equals to sine lambda pi over pi and then into brackets 1 over lambda minus minus 2 lambda into cosine of pi over lambda squared minus 1 squared minus cosine of 2 pi over lambda squared minus 2 squared plus cosine of 3 pi over 7 lambda squared minus 3 squared, then other terms, then close the brackets so that now cosine of pi, which is the same as 180 degrees, so cos of 180 degrees is -1, and then so this will be cosine of lambda f pi. So I can divide through even by sine lambda pi, so to give me 1 over pi into 1 over lambda minus 2 lambda into cosine, so that's -1. So -1 raised negative 1 over lambda squared minus 1 squared minus, so cosine of 360, that's positive 1. So 1 lambda squared minus 2 squared, and then cosine of 360 plus 180, that's negative 1. So negative 1 over lambda squared minus 3 squared plus other terms of that pattern. So this will give us, this cos over sine is the same as cot, so cot lambda pi. So I can multiply through by pi, so I have pi equals to 1 over lambda, and then so I factor out minus, so then I have, so this will be plus, so plus 2 lambda over lambda squared minus 1, and then plus 2 lambda over, so this square, lambda squared minus 2 squared plus 2 lambda squared minus 3 squared, and then plus, even the next one you can actually get from the trend here, 2 lambda over lambda squared minus 4 squared plus etc. So therefore, from this one you can say pi cot of lambda pi is given by 1 over lambda, then plus, so summation n from 1 to infinity, this can be written as 2 lambda over lambda squared minus n squared. So that is what you get. So therefore, this is the Fourier series ends at this point here. This part is what defines the Fourier function, and from which you can obtain other series by replacing the values of x by some values. So similarly, replacing x for 0, we get, so we are replacing this equation here, what we have said that the Fourier series. This equation here is where we are replacing x for 0. So let's call this one star, this Fourier. So we get 1 over sine of lambda pi is given by 1 over lambda pi plus twice summation n from 1 to infinity minus 1 raised power n, and then lambda pi over lambda pi squared minus n pi square. Now, if we replace theta for theta for lambda pi, so we get 1 over sine theta is the same as 1 over theta, because this is 1 over lambda pi, plus summation n from 1 to infinity minus 1 power n, and then 2 theta, theta squared minus n pi squared which is the same as 1 over theta plus summation n from 1 to infinity minus 1 power n into we have 1 over theta plus n pi, and then plus 1 over theta minus pi. So that's from this one we have obtained an expansion for the function f of x or f of theta equals to 1 over sine theta. So that is what you're supposed to do, that question.